Okay, my extremely good friends, Roger once again, Mud Fossil University, and what you see there is obviously the sun. Now I am going to let this play, and every second is one day. This is 10 years of the sun spinning. Now, where you see extreme interactions, they stay extreme interactions in the same place. In my opinion, there is some different chemistry there, or there is a pinnacle here, like a mountain or something, that is rubbing against what is out here, which is the ether of space. And I can show you that ether, and I can literally prove it in a number of ways now. This is an extreme interaction. In this, you see, this is not moving around. They're going, moving and giving the same interaction from that same space. It's not like that's drifting around here and there. There is something causing more interaction in these spaces. Now, as the sun moves and spins, and all of us move through the galaxy on the arm of the Milky Way, the sun is sometimes scrubbing this area real hard and not hard over here. You see it? And sometimes it's scrubbing real hard over here and not hard over here the next day as it spins through and moves. Let me show you what I mean by that. Okay, this is the galaxy, and it's spinning like this. This is what's called an accretion disk. And at some point it will collapse into a ball. Now, there's a whole other story about that. But you know, I always hate to talk about space and everything because there are going to be a bazillion different flat earth people attacking me. But this might have been what the earth was like at one time, around a flat accretion disk, and it popped into a ball. They will never accept that, and I am prepared for the attacks. Now, this is the galaxy spinning. All right, now this is us being dragged through the arm of the Milky Way, spinning. The sun is spinning, we're all spinning around the sun, we're all being dragged through what's in front of us. So there's going to be a lot of different interactions, and the sun is getting heated extremely a lot because it's much bigger than the rest of us, but we are getting heated as well. The sun's corona way outside the outside, millions of degrees, the sun is 6,000. We are thousands in our outside atmosphere, the ionosphere, magnetosphere, and on our surface it's 90 degrees or so. That's the reason, because we're scrubbing through the particles, which are the ether, which John Glenn saw. Now, I'm going to leave this one up. It's John Glenn's Fireflies Are the Ether. It's too long, though. It's 25 minutes long, but it shows, like, here, let me just show you. It shows the light research, and it shows a lot of stuff that I'm not going to show in this one. But I am going to show John Glenn what he says as he's going up through space. Here we go. Here he goes. Now, what's happening, he's going up through the atmosphere, and then he hits the ionosphere, which is the shell of particles that starts into the ether of outer space, and they are surrounding his capsule as he goes through it and lighting up in the background.
They swirl around the capsule and go in front of the window, and they're all brilliantly lighted. They probably average maybe 7 or 8 feet apart, but I can see them all down below me also.
All right, they average 7 or 8 feet apart because that's the magnetic influence around the particle. A huge, huge magnetic influence. Out there, 7 or 8 feet apart. On the Earth, they're going to be very close together. And in molecules, they're going to be crushed into nuclear particles, which have a nucleus. But they all start out like this. Every electron is like this. And as far as I can determine, all of the molecules on Earth that are complete molecules, and they're not just electrons. Because electrons are heat and cold. They move and they just flow back and forth, electricity, heat, and cold. Nothing more than these particles. However, when you batch them together into a ball and then you create atoms, it's a whole different situation. And the only way I can see that atoms are created is from life. You know, this is the raw material of life. Now, he went up here and, let's see, he's up here, let me see what I'm talking about here. I don't know, I'm just bouncing around. Here goes.
Sunrise, there were literally thousands of them. It looked like just a myriad of stars. Over.
Now, I want to say something. Everybody says, oh, you can't photo these things with a cell phone. Oh, you can't see. Yes, you can. They are enormous when you know what you're doing, and Rod does. Oh, that's right. I remember saying that now. And Rod is doing the stuff he did. You see back here? Look at this. And I'm not going to get too crazy. I'm going to leave this up. You can come up and look. This is light accelerated. When it started to come through that Venturi, it was like that in a ball, in a box. There was a black and a white ball. And the white balls explode. Those are called fermions. The black balls just rolled away. Absolutely rolled away. Nothing. It's exactly what they want for the bosons. Now they're talking about bosons as being dark energy, and they might be, because I have no way to account for them just being able to walk away and then walk back in over here. This is a very confusing situation, to be perfectly honest, but it's exactly what they say. They know this happens. They can't show it because we're working with light, Rod and I. They are working with atomic particles, which are just like hitting mountains together, and then they're digging through the debris. We're started out with the tiniest bits. Now, I'm going to leave it at this for today. But the ether, well, let me just show you one more thing. All right, remember how I said we scrub through the ether that's in space, because these are nothing more than particles, and they get denser and denser and denser because they're being sucked down to Earth attractively magnetically. Now, as they get down deeper and deeper and they condense closer to the Earth, this is where you get lightning and all kinds of magnetic interactions, and it also glows like hell because it's scrubbing. It's just like scrubbing. It's just like heated. Now watch as it goes. You watch the scrub, see it?
They're only very slightly under.
See it? Now, before we go any... Anyway, I probably made that same comment. But these are tiny little particles. He said they're like a 1/16 of an inch or smaller. But they're glow. You can see them glow. Now, Rod has a technique that he's found a way to see them as I showed you. All right? I'm going to leave it at that. But come up and watch this one. This is a pretty good one, too. All right, I just want to make a mention of these are not anything other than light particles. And I can make that statement unequivocally because they are only seen against dark background. When there's no, they are their own light source. If they were light particle, I mean, if they were ice particles, when you came into the sunlight and they were bathed in sunlight, then you would see them because then they would give off light. They are giving off their own light from darkness. That is the signature of a light particle. Totally opposite of what you would expect to see when light hit it. As soon as light hits it, it goes away because it becomes incorporated into the light that is in space. It doesn't illuminate it, it just becomes part of it. Okay, by the way, I had to update my whiteboard. This is my new whiteboard. Electron flood theory makes it pretty simple. There's nothing but electrons. This is a helium. Now, the helium has all of its positive particles towards the center, the negatives on the outside. I go through all this in my other videos. And there's 7,350 electrons make the nucleus of a helium. Now, it's in a soup of electrons. It doesn't really have two electrons out here that are just in exact orbitals. It's in a soup, and it only can control so much of the soup. That's the new theory. Strong and a weak force. Now, this is my whole new whiteboard. And that was the old one. And even that was mostly into electron flood theory. There's a lot of little details. I'm just teasing around. But this is basically it. That really is basically it. 100% electrons. The more you add them together, the bigger the ball will get. It will always have a negative outside crust, keeping the soup from invading it. Now there's not orbitals anymore. It's a soup. And I show that in the new atomic pictures. They can actually see the atoms. All right, this is from the same video, the bigger, longer one. That's the actual nucleus. These little regions here, and I'll explain it in the other one, they're resonance frequency electron globs, really. And that's the bigger they get, the more complex they get. It's really not not a big gigantic leap to understand this. And then I go through all my other stuff again. And then this is this is how they actually move the electrons around the nucleus. And that's exactly what's happening in the sun as it scrubs, and you watch them move.
A magnetic field. So all they're doing is they're taking just almost like a bar magnet.
And that's just
and they're
nothing.
pushing it down here.
And that's nothing more than the sun moving towards us through the bar magnet of space, which is the ether.
Which is going to force the other electrons to move away. And this is one atom. It's one atom. And these are all the electrons. So they're going to push the electrons around that ball, which is the atom, the core, the nucleus.
This is just like our sun.
Did you see where it went? It went around the ball. You see it? It's wrapping around. It's forcing it to wrap around the ball because of the magnetism.
In all kinds of fields from.
All right, so that's enough for that. All right, I love you all.